So we're going to look at circular and periodic functions. So we're actually, the first objective, we're finding values of trigonometric functions based on the unit circle. Now what you see here, this is called a unit circle. And the coordinates, so we have a coordinate here on the x-axis, and this is at the coordinate of 1, 0. And on the y-axis, this is at 0, 1. On the minus x, this is at minus 1, 0. And on the minus y, this coordinate is at 0, minus 1. So we'll have an angle that is formed on our unit circle. So if our angle was here, this point where it intersects with the unit circle, this is our coordinate of x and y. Now, if we previously, we formed a triangle, and this was theta, we would find our value, maybe for sine or cosine. So this is done. So sine of theta will be the y value divided by the r value. So r being the radius. So this is our x and this is our y. If we wanted a cosine, this would be x divided by r. We can look at these values and we can see that the sine of theta, y over r, now r is 1. So it means that the value here would just be y. And the cos of theta, r is 1, because this is just one unit. It'll be x. So we can say that the sine of theta is the y coordinate and the cosine of theta will be the x coordinate. So let's have a look at an example. So example 1, find sine and cosine given a point on the unit circle. So the question says the terminal side of an angle theta in standard position intersects the unit circle at the point a half root 3 over 2. Find the cosine of theta and the sine of theta. So if I was to draw my unit circle, so the point here where it intersects, this is the point a half, comma, root 3 over 2. So this angle here formed in the first quadrant, so let's label that x and y. This is, okay, 1 unit. If we were to draw and do opposite over hypotenuse or adjacent over hypotenuse, we would actually have the same value. So this is what we're going to do. So the sine of theta we said was y over r, which we said would just be y. So if we look at our point, the y value is root 3 over 2. So the sine of theta is root 3 over 2. Our cosine of theta, we said, was x over r, which was just x. Our x value is a half. So the cosine of theta is a half. So guided practice, it's number 1. The terminal side of an angle theta in standard position intersects the unit circle at point 3/5 minus 4/5. Find cos of theta and sine of theta. So we know that x is equal to cos of theta, and we know that y is sine of theta, and we know that the point of intersection is at 3, 5 minus 4, 5. So if x is equal to cos of theta, the x value is 3/5. So cos of theta is 3/5. And if sine of theta is equal to y, and the y coordinate is minus 4/5, sine of theta is minus 4 over 5. Okay, so we have check your understanding, a question. The terminal side of angle theta in standard position intersects the unit circle at each point. Find the cosine of theta and the sine of theta. So question 1, the point is 15 over 17 and 8 over 17. And question 2, the point is at minus root 2 over 2 and at root 2 over 2. So try those. Okay, so we know that the cosine of theta is equal to x, and the x value is 15 over 17. So the cosine of theta is going to be 15 over 17. And we know that the sine of theta is equal to the y value. So sine of theta will be 8 over 17. Question 2. So the cosine of theta is equal to minus root 2 over 2. And the sine of theta is positive root 2 over 2. So we're going to look at periodic functions. So a periodic function has y values that repeat at regular intervals. One complete pattern is called a cycle. So let's write that down. It's called a cycle. And the length is called a period. So let's look at an example. So periodic function, we have one here. So we're looking, it says has y values that repeat at regular intervals. A complete pattern is called a cycle. The length is called a period. So the pattern repeats here. So this here would be called one cycle, and it would be called a period. So this is the length of the cycle. So we can say the period is at pi. So 0 to pi, so the period is pi. It repeats, and the next time would be at 2 pi. Right, so the guided practice, graph a function of period 4. So we need to draw, so first of all we can do our axes, and we can say this is 1, and this is at minus 1, and this would be here minus 1. So we're looking to repeat a pattern that is going to be at 4. So we could label this and say that this is 2, 4, 6, 8, 10, 12. And we could have a pattern that's going to start, you could start at 0, or you could start at 1. So we're going to start at 0. So we're going to say from here, and then it's going to come down here. So it's going to go up, and it's going to come down. So it's going to go up, and it's going to come down. So if we're looking when the pattern repeats, we're looking at this distance here. And we can see from this distance 0 to 4. So the period is 4.